Okay, now that we've looked to see how to make frequency distributions in R, let's take a look at how to make graphical presentations or graphs. Now recall that in an earlier video we already brought in some data from SPSS and we stored that data in an object called datasets, which is a data frame. Let's just look at the namespace of our data frame dataset. So we'll just run the names function on the dataset object. And then if we just look at our output window, we can see we have the following variables: year, ID, child, age, education, father's education, sex, race, and so forth. Okay, so in this video we're going to look to see how to make a pie chart of race. We're also going to make a bar graph of the variable class. We're going to make a histogram of education and then a line graph of education. So let's look at the code for each of these and then we'll look at the output. Okay, so in order to make a pie chart for the variable race, the first thing we need to do is we need to make a frequency table. So I'm going to make a new object called race.freq. And again, this is just an arbitrary name that I've picked. I've used a period because that's a naming convention that R will recognize. I'm going to use the tables command to save the output of a table function into this new object. And I'm going to run the table command on the race variable, which is found on the dataset data frame. And I'm going to separate these two names with a $sign so that R knows that I'm pointing to a particular object in the data frame and a particular variable within that data frame. So I'm going to run this. And then if I wanted to, I could just print the resulting frequency distribution of race by running the print command. I could also take the sum of these frequencies to get the total number of cases. So I'm just going to run these two together. And then if we zoom in on our output window, we can see that we have the following frequency distribution of race. So 1, which I know is coded white in the GSS, there's 1,477 whites. There's 301 blacks, which are coded 2, and then other races, there's 196 for a total of 1,974 people. Now, if you're running this, R may actually treat your race variable from the GSS as a factor because there may be value labels associated with it. In my case, that's not true. So I didn't have to do anything to this variable. But in your case, you may need to first transform race into a numerical variable. So go back to one of my earlier videos, and that will show how to do that. But we can just proceed with what I've got right now because it'll work properly. So what I'm going to do is I'm going to actually create a new object called race.labels. And the object is going to include the value labels that I'm going to include in my eventual pie chart. And so I'm going to put them into a vector. And in R, a vector is basically created by using the C function and then just adding the different elements of the vector separated by commas. Okay, so my race labels vector is going to have 3 elements. 1 is going to be called white, 2 is black, and then 3 is other. These are just the codes for the different categories of race. So I can run that, and then R will recognize my race labels as a new object. Okay, so now moving on to our actual pie chart syntax. So the command that we're going to use in R is pie, and we have to feed it some information in order for the command to run properly. So the first thing we need to do is need to tell it which object we're going to make the pie chart from, and that's going to be the frequency distribution of race. So that's basically saved in my object race.freq. And now I'm going to include a couple of options in my syntax. So the first thing I'm going to do is I'm going to create some labels for each of the different slices of the pie, and they're going to be the labels that I just created up here. And so the value of the labels argument is just going to be the race labels object. Again, I put a comma to indicate that I'm going to include more different options. And so I can also include different color values in my pie chart. So this col argument is basically telling me what the different values of the slices in terms of their color content are going to be. And to get that, I'm going to basically take my race frequency object. I'm going to figure out its length. It's going to have a length of 3 because there are 3 different values, white, black, and other. And then I'm going to use the rainbow command, which basically is a rainbow palette of colors. And so I'm going to choose 3 colors from the rainbow palette of colors based on the length of this object, which is going to have 3 different entities. And again, I separate this with a comma. I'm also going to put a title on my pie chart. And so this pie chart I'm going to call Figure 1 Pie Chart of Race. And titles are indicated with the main argument. So main is going to be equal to, in parentheses, the title of my chart. And again, I have another comma here. And then I'm going to put some kind of a note at the bottom of my pie chart. This one's going to have the note that says n equals 1,974, my total number of cases. I have a \n here. In Python, in R, that, like in Python, that indicates a new line character. And so this is not something that's going to be part of your output, but it's going to know that it needs to put a new line before the next text is going to be written. And so in the new line, I'm going to be writing the source of the information that comes from the GSS 2012. And I'm also going to put another new line character, which will add just another carriage return or enter at the end of the line. So we can run this. And then R will create a pie chart for us. Now let's zoom out. Notice that the pie chart is actually right here. And so if we wanted to, we can just save this file. It looks like the majority of cases here are white. Black is a little bit higher than other. So all we have to do is basically just export this. And if we export this, we can export this and save it as an image. And then it'll be saved in our working directory, which we set earlier, which I showed in an earlier video. And so that's how to make a pie chart. Suppose that we actually wanted to make a little bit of a fancier pie chart. So let's take a look at another type of pie chart. Let's look at a 3-dimensional pie chart. So in order to do this, we're going to have to install another package in R, and that's the Plotrix package. And so I've already installed it, but for you, you're going to have to highlight this and run it. And for you, it'll install this package, Plotrix. I'm just going to comment this out because I actually don't want to run it. And once you've installed it, you can bring it in as a library so that all the Plotrix commands are available in your R session. Okay, so one of the commands that we're going to be using is pi3d. So this will make a 3-dimensional pie chart. And again, we have to provide some arguments for this command in order for R to correctly produce the pie chart that we want. So the first thing that we're going to do is we're going to provide the object on which this command is going to be run. And so we're going to use the race freq object, which is just the frequency distribution of race as our data for the pie chart. And again, we're going to add some labels. Remember that we created labels up here. Now, you may not need to do this if your version of the data set already has value labels attached to it. But if it doesn't, this is something that you should do in order to make sure that you have those labels. And then again, we're going to use the rainbow colors based on the length of the race frequency. I'm actually going to explode the pies a little bit. So I've added this explode option, and I've told it how much I want to explode the pie, the various slices of the pie. This is basically like how far set apart they are so they can more easily see the patterns. And then again, I'm going to provide a title. I'm going to call this figure 1b using the main argument, and I'm also going to provide my note at the bottom of the table that includes the number of cases and the source, and I have some end-of-line characters to provide some carriage returns at the end of these things so they're written on different lines. And so if I highlight this and I run it, and then we zoom out, so we can see that R made a nice looking exploded 3-dimensional pie chart of race. And so again, if we click on export, we can save this as an image. And so again, that's something that we can just save in our working directory and put into another document and discuss it in some kind of a report. Okay, so that's basically how to make pie charts in R. Let's look at how to make bar graphs. Okay, so I'm going to make a bar graph of the variable class. And so I'm going to start the same way I did with my pie chart. I'm going to make a frequency distribution of the variable class. So I'm going to use the table command, and I'm going to run the table command on the following object, the data frame data set. And within that data frame in the variable class, again, separated by a $, I'm going to make that equal to some kind of an object in R, which just takes the arbitrary name here I provided, class.freq. Once I run this, I can print and look at the sum of that new resulting object. And basically here I've just used the cbind command and the print commands. just to make the formatting look a little bit nicer, just so we can look at it. And so if we go to our output window, here are the different classes, 1, 2, 3, and 4. This is basically lower class, middle class, working class, and upper class. No, I'm sorry, lower class, working class, middle class, and upper class. The various frequencies for each, and there's a total number of cases of 1,957. Okay, so going back to my script, now notice that my value of class isn't labeled. Yours may be, so you may not need to do this step, but I am going to create an object with the labels of class. It's going to be a vector, which is denoted by the C, and then in parentheses the values that I want to be represented in that vector. I'm going to have the different values of class, lower, working, middle, and upper class. Okay, one other thing I'm going to do that's a little bit different is I'm going to add a note to my graph, but I'm going to do it in such a way that I actually change the alignment. I'm going to use left alignment. So one thing you can do is you can actually look at the help menu for this title command. So the title command is something that I'm going to add to the bottom of my graph. And so if you run this, and you zoom out, you should get some documentation for the title command. So just kind of read through that, make sure you sort of understand how that works. I'm not going to go through it in detail here. Let's go back to our script. So here is basically the basic syntax for my bar graph. The command itself is called bar plot, but notice again that I'm following that up with another command, title, in which I have basically the same syntax that I used previously. But this time I'm going to include another argument, adj equals 0. So this is the kind of alignment, and 0 is a code indicating that I want a left-aligned note at the bottom of the table. So that's a little bit different from the syntax we looked at the bar graph, but this will make the spacing of the graph look a little bit better and nicer. Okay, so for the bar plot command, again, I'm just going to provide some kind of object with the thing that I'm plotting, in this case the frequency distribution of class, and I'm going to include some options that are separated by commas. So xlab here is just the label of the x-axis. I'm going to call that subjective class identification, and notice that I have a new line character to indicate that I want a carriage return after these words, just to change the spacing a little bit. My y label here is going to be the frequency, because I'm graphing a frequency. Now you could also graph the percentage. You just have to divide each of the frequencies by 100 and then graph it, and you can call that percentage. Names.arg is basically the names that I'm going to assign to each of the individual bars, and they'll take on the values of class.labels. That's that object I created here, which is the vector of names for the different classes. Main is just going to be basically the title, like we saw previously. This time I'm going to call it bar graph as subjective class identification. And I've already discussed this title command that has basically a note at the bottom of the table. It follows the same basic format we saw previously. So let's just run this. Making sure that we first run this so we don't get an error. And let's run this. Okay, and now basically we can kind of zoom out and notice that we have our bar graph here. I can stretch this a little bit. And so we can see that it made a nice looking bar graph that, again, we can kind of export, we can save to an image file, and we can use later. Okay, so I'm going to resize it back. And let's look at a sort of final set of graphs. I'm going to make a histogram of education. So I actually don't need to create a frequency distribution this time. I can just use the actual variable itself when I point to the data frame that it's located in. So the command is going to be hist. I have to tell it which object I'm going to run the histogram command on. So I'm going to run it on the data frame data set, and within that data frame, the variable education, again, separated by a $sign. So that's how R knows that you're referring to this variable in this data frame. I'm going to tell it how many breaks I want. I know that there's 21 different categories from 0 to 20, so I'm going to tell it that I want 21 different bars. I'm going to use my X label to label my X-axis education in years with a new line character, all in quotation marks. My Y label is the frequency, and so I can again put that in quotation marks. Here is the title of the graph. which I provide with the main argument. Notice again, all these are separated by commas. And this will be figure 3, histogram of years of education. And then I'm just going to include the title command to put a note at the bottom of the table with the number of cases and the data source, and left aligned with the adjust option. Okay, so if I run this and I zoom out, notice that I have my histogram right here with all of the things that I asked for. I can export this to a file if I wanted to. I can describe it later. So very simple to make a histogram in R. Let's now look to see how we make a line graph in R. And so line graphs are a little bit more complex, so you actually have to create some kind of an object with the frequencies. So we'll use the table command on the education variable found within the dataset data frame. I'm going to store that as an object, educfreq. We'll run that. And then, again, I can just kind of print the resulting frequency distribution and the sum of frequency to get the total number of cases. If we look at our output file, notice that we have basically a frequency for every value of education for a total number of cases, 1,972. Okay, so now we can just basically look at the actual syntax for the plot. It takes the plot command. I have to tell it which object on which to run it. That is education.freq. I have to tell it what type of plot I want. And if you look at the help menu for plot, L is actually the code that's designated for a line graph. And then I'm going to add some kind of an X label. Notice that I could have put this on the next line. It doesn't really matter. It's a bit flexible. So if I wanted to, I could actually do something like this. But it would recognize this command, this option nonetheless, because it's separated by a comma. So I'm going to call this education in years with a new line character. I'm graphing the frequency on the y-axis, so I label that accordingly. I'm going to put in a title, line graph of years of education, and then I'm going to use the title and the sub option to basically put a note at the bottom of the table telling me that I have 1,972 cases, and they're going to be left aligned. So I'm going to run this, and then if I just zoom out, here's the resulting line graph. So it looks a lot like the histogram. It looks like there's very few people at sort of low levels of education. 12 years of education looks like a peak, as well as 14 and 16. These are probably like terminal degrees, like a high school degree, maybe an associate's degree and a college degree. Maybe we have something here that's a master's degree and PhD. On the whole, it looks like the range is pretty wide from 0 to 20 years of education, but most people are sort of in this range, the upper values of education, especially kind of in the middle. And so that basically tells us how to do graphing in R